Alright, so here's another rationalise the denominator. So this is a fraction. I'll just write it over here again. So it's got a numerator and it has a denominator. So the denominator is the one below, denominator. And we want to change this into a rational number. So we want to try and change this and try and get rid of this surd so it doesn't actually appear in the denominator. And again, it's just a skill that we practice, but later on, maybe when we try and add fractions, if you tried to add fractions that had denominators looking like this, and we could change that denominator into something like this or this, a rational number, then when you're adding fractions with rational denominators, it's quite easy to make the denominators the same, okay? So the whole point about this is to get rid of the irrational or the surd piece to make it into a nice rational number, something like this. All right, now you just have to know the trick for this, because the trick is that we're going to change the look of this denominator by multiplying the denominator by a specific amount. But of course, whatever we do to the bottom, we have to do to the top. So the bottom I'm just going to copy and paste and sign change, right? Copy, paste, sign change is the key. Now when we multiply the bottom by 9 plus 2 root 3, we must also multiply the top by 9 plus 2 root 3. This is going to be maybe a little bit complicated, but I think the top I can do as it is. And the top I'm going to do just by expanding, so it'll be 5 times the 9, right? And then 5 times the 2 root 3. So I'm going to go ahead and do that straight away and write down the answer. So the 5 times by the 9 will give me 45. And the 5 times 2 root 3, well, that is 5 times the 2. And the 2 root 3 is just 2 times root 3. So when we do this, it'll be the 5 times 2 first, which is 10, and then it's 10 lots of root 3. Okay, so that's 45 plus 10 root 3. Now for the denominator, I'm just going to take it down below, and I'm going to use the grid method again. I'm a big fan of the grid method. Just helps me with my organisation. So on the top, I'm going to put 9 and then negative 2 root 3. And down the side, I'm going to put 9, and this will be positive 2 root 3. And basically, you just multiply the numbers into the relevant section of the grid. Let me show you. So 9 times 9 would appear in here. The 9 times the negative 2 root 3 in here. Can you see? And then these guys multiplied together, and the answer would appear in here. So it's just an organisational system for expanding brackets, we call it. So let's go ahead and do that. So 9 times 9 is going to be 81. And then 9 times negative 2 is negative 18, and that's lots of root 3. And then down here, can you see, that'll be 9 times 2, which is 18 root 3. And finally, I'll have negative 2 times positive 2, that'll be negative 4, and I'll have root 3 times root 3. And can you see what will happen with that piece there? Root 3 times root 3. Well, that'll just give me 3. Right, and negative 4 times 3 will give me negative 12. Okay, so each of those pieces might take a little bit longer than some of the other pieces. But now can you see what's going to happen? Because I've got 18 root 3, subtract 18 root 3, which cancels each other out. So when I said, back to the original, copy, paste, and then sign change, the sign change ensures that always, 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 these two pieces here with the surds, the roots will always cancel out, and then you'll always be left with a rational number here and a rational number there. And so when we put those two pieces together, we will have 81 minus 12, and 81 minus 12 is 69. So 69 is the answer we're going to put in for our denominator. So our denominator is 69. Now, there are ways that you might take this a bit further by doing some factorising, but I'm going to leave it there for now. In fact, this I don't think actually factorises any further anyway.